Okay, today we are on to section 2A.4. We're going to talk about the distributive property. Again, this is probably review for a lot of students, but it's a really important concept and one we definitely need to go over. So today the learning target is that we can simplify expressions by using the distributive property and combining like terms like we went over yesterday. First of all, I think we ought to review how to multiply terms together, right? When you multiply terms together, you multiply the coefficients together and you just tack on the variables, right? So in the first example, if I'm multiplying 2 times 3x, I need to multiply the 2 and the 3 together, get 6, and tack on the x. The answer is 6 times x, or 6x. In the second example, I have a negative number times 5y, so I need to pay attention to my signs. I need to multiply negative 3 times 5. Negative 3 times 5 gives me negative 15, and then I have times y, or negative 15y. In the third example, I have 2x times 4y. Now let me remind you why this works. 2x really means 2 times x. It's just when you have a number and a variable being multiplied together, you don't need to have a dot between them. But you could. And then the parenthesis means that I am multiplying times 4 times y. Essentially, this problem is 2 times x times 4 times y. Now we have this cool little property called the commutative property, which says that when I am multiplying terms together, I can put them in any order I want to. So I'm going to take these terms and I'm going to rearrange the order. I'm going to keep the 2 first, but then I'm going to put the 4, then the x, then the y. And then the answer becomes obvious. The answer to this is 2 times 4, or 8, times x times y. And the best way to write 8 times x times y is 8xy. And last up, I have 6x times 3x. Let me do the same thing with this one. This is really 6 times 3 times x times x. It's 4 things being multiplied together. Now we all know what 6 times 3 is, right? The 6 times 3 gives us 18. But what's x times x? Well, you might remember from chapter 1, when you multiply something times itself, you know what you're doing to it? You're squaring it. X times x is x to the second power. So when I multiply 6x times 3x, I'm actually getting the 6 times 3 is 18. The x times x is x to the second power. My answer is 18x squared. All right, good. We all remember how to multiply terms together. Because if you can multiply individual terms together, then the distributive property becomes easy. All right, what does the distributive property actually say, or what is it actually used for? The distributive property is actually used to do this. The distributive property is used to multiply a single term times a group of terms that make a sum or difference. There's a lot of good math words in there. I want to go over just a couple of them. We know what a single term is, and hopefully we know what a group of terms are. What do we mean by a sum or a difference? Well, that means that you would use the distributive property when you're multiplying a single term times a group of terms that have been added together, that would be a sum, or a group of terms that have been subtracted from each other, that would be a difference. What you would not use it for is if you had something like this. You would not use the distributive property to multiply 2x times 3 times 4y. I'll get back to that in a second. But the terms that are grouped together, they need to be a sum or a difference if you're going to use the distributive property. And I have a couple examples here that are written in algebraic form, which is just variables. The first one I have a times b plus c. And the distributive property says that you can multiply the a times each term in the group. So you would multiply the a times the b plus you would multiply the a times the c. Your result would be a times b plus a times c. The big thing to get out of that is simply that the single term, the a, gets multiplied separately by each term in the group. And the same is true if you have a difference. The a gets multiplied by the b, this time it's minus, and the a gets multiplied by the c. Or, I think I wrote here to sum it up, you multiply the single term outside the parentheses times each term that is inside the parentheses, right? The biggest thing to pay attention here to, in my opinion, is the signs. When you multiply, you gotta pay attention to the signs of both terms you're multiplying. And this goes back to a couple days ago when we were adding and subtracting. Don't forget. When a term has a sign in front of it, it might look like a plus or minus sign, but that is also the sign of the term. So if it's got a minus in front of it, it's negative when you multiply. Put the sign on each term when you multiply. Let me go through some examples. Here we go. In the first example, I multiply 3 times the quantity 2x plus 5. So that would mean I would multiply the 3 times the 2x plus I would multiply the 3 times the 5. Now, I don't always write this line out that I just wrote. A lot of times I just use arrows to show that I multiply like that. That would tell me I multiply 3 times 2x, and I would go ahead and write the answer down instead of writing down 3 times 2x. And I would draw another arrow that I am multiplying 3 times 5, and instead of writing down 3 times 5, I would just write down the answer. Sometimes I think it's a little confusing to write it all out actually, but I'm going to do it on these 4 examples. I want to pay attention to some signs in a minute. Anyway, in this example, when you multiply 3 times 2x, you get 6x. And when you multiply 3 times 5, you get 15, and it's positive. You gotta have a plus sign in there. And you get 6x plus 15. Those are not like terms. They cannot be added together. That is your final answer. In the next one, I have a negative sign in front of the parentheses. This reminds me of the old coefficient game we played. We played name that coefficient. What is the
What
coefficient
is the
of the term negative x?
That's right.
It's
negative
one.
There is a secret
negative one in front of the x.
And that is
true
with the
negative
sign
sign
in front of the parentheses.
Also,
There is a
negative
negative
one in front of that parenthesis
when it has a
negative sign.
So the number
I am
distributed
here
is
the negative one.
I need
negative one times each term.
Negative
one times
x.
Negative
Negative
one times
This is big here.
times
negative
2.
Right? There's a
There's
minus
in front of the 2. So when I
multiply
multiply
the
the
negative
negative times
it,
I need to make
I
sure I
need to
pay
make sure I
attention
pay
to that
attention
being
to that
a
being a
negative 2.
Why?
And
negative
one
times
z.
The 3z
is positive. So when I go ahead and multiply these,
I end up
with
negative 1 times x
is
negative
1x.
1
Negative 1 times negative 2 is positive 2
with a y on it.
Positive
Positive
2y. And negative 1 times 3
is negative 3 with a z on it.
Again, the signs it seems to me turn out to be the most common mistake that students make when they are adding and subtracting and multiplying. And the big thing is because adding and subtracting has different rules than multiplying, right? When you're adding and subtracting, how do you decide what sign goes on the answer? Well, it's the sign of the bigger number, right? But when you're multiplying, it's not the sign of the bigger number. Multiplying has a different rule. When you're multiplying, if the two numbers have the same sign, like negative 1 and negative 2, the answer is positive. If the two numbers have different signs, like the negative 1 and the 3, the answer is negative. Doesn't matter. The 3 is bigger than 1 and 3 is positive. When you're multiplying numbers with different signs, the answer is always negative. All right, the next example shows what happens when the single term is on the other side of the parentheses. And what happens is it doesn't matter. It's still a single term times a group.
I need to multiply 2 times each thing. The 2 times the x and the 2 times the 5. 2 times x,
better written as 2x,
and the 2 times the 5 is 10.
I'm done with that one. And last up, I have a negative 2 times each term.
So it might look like this.
And in this one, I'm not going to write down the middle step. I'm just going to use the arrows. Negative 2 times positive 3 gives me a negative 6x. And negative 2 times positive 7 gives me a negative 14. My answer is negative 6x minus 14. See how easy that was? Just got to pay attention to the signs. Okay, last up, we're going to combine all of our skills over the last couple days, and we're going to simplify an algebraic expression. All right? Simplifying an expression means write an equivalent expression in simpler terms. Right? All it means to simplify an expression really is do whatever operations you can to make the expression be reduced or simpler. This is different than a couple days ago when we used the word evaluate. Right? When you evaluate, you have to put a number in for the variable and do all the operations and end up with a single value. But when you're simplifying, you leave the variables. You just do any operations you can. For us, this will usually mean multiplying terms together by using the distributive property and combining any like terms that need combined. And you're not going to want to forget the order of operations, right? PEMDAS. This is important because if you distribute and combine like terms in the same problem, you must do the multiplying first, and the combining of the like terms second. Combining like terms is adding, subtracting. That gets done last. When we do the correct order of operations, right? All right. So an example A. I have two things to do. I need to multiply, and I need to combine like terms. And the first thing I'm going to do is I'm going to multiply. I'm going to multiply the 3 times the 2x and the 3 times the 7. 3 times 2x gives me 6x. 3 times 7 gives me 21. And I haven't used the minus 2x yet, but I'm going to bring it down. This is what I get when I do just the multiplying. Now I'm ready to combine any like terms I can. And the like terms I see are the 6x and the minus 2x. Well, 6x minus 2x is 4x. The plus 21 has nobody to combine with. My final result is 4x plus 21. In the second example, I am not going to make the mistake of adding the 5 and the 2 together. I know that I need to multiply before I add. This is what I need to do first. I need to do the 2 times 4x minus 8. So again, I'm going to use the arrows. And this gives me 8x 2 times 4x. And negative 16, that's 2 times negative 8. Now the 5 did not get used, so 5 is going to come down and leave me with that. Now I'm ready to combine my like terms. Of course, my like terms are the 5 and the negative 16. Those guys can be combined. Let's see. They had different signs, so I would not add them together. I would subtract them. And when you subtract 16 and 5, you get 11. And 16 is the bigger number, so he gets to put his sign on the answer. Negative 11. The plus 8x has nobody to combine with, so we're just going to leave it plus 8x. My final result is negative 11 plus 8x. Now, some people like the variable term first, and that is perfectly acceptable. I could put 8x and the minus 11 second, and that would be exactly the same answer. As long as I keep the signs correct. The 8x was positive, stays positive. The minus 11 stays minus 11. All right, last up. I have a big problem to do. It looks like I have some multiplying right here. So that is what I'm going to do first. And the important thing here is to make sure that when I multiply, I remember that that's a negative 4. Pay attention to the signs. So let's see. The 12 is not being used. I'm just going to bring him down. Now I've got this negative 4 times each term in parentheses. Negative 4 times 3 is negative 12x. And negative 4 times positive 5, a negative times it is a negative 20. And the minus 3x at the end is not being used yet. This is what I should get when I do the multiplying part of the problem. Now I need to combine my like terms, and my like terms are the 12 and the negative 20. Now let's see, am I going to add those and get 32? No. They have different signs. So I'm going to subtract 12 and 20. When you subtract 12 and 20, you get 8. And 20 is the bigger number, so he gets to put his sign on the answer. And then I also need to combine negative 12 and negative 3x. Those guys are like terms. Those guys have the same sign, so they would get added. 12 and 3 makes 15. And 12's the bigger number, he gets to put his sign on the answer. Negative 12 and 3 make negative 15 when you combine them. I hope that helps. I hope you now understand how to distribute and combine like terms. Good luck.